today in pre-cal we talked about piecewise functions. What a piecewise function is one that does something for a while and then it changes that habit after a certain amount of time or a certain domain on the graph. For example, on this number 1, this one kind of looks like a parabola for this part, right? And then here it becomes a constant function. So it is something that changes over time. First, we want to start by learning some things about domain and range. So the first blank in your notes is domain. And the domain is all of the x values when you look to left to right. So that's basically saying if I look across the x-axis, where is there a value on the graph? So everywhere that there's a value, that would be a part of the domain. For range, we're talking about the y values. And I'm saying, looking from the bottom to the top, everywhere I look, where does something happen from bottom to top? In the y value, what is that range? So on example 1, if I start coming in from the left to look at domain, remember that this arrow means that that goes on forever and ever and ever. So I'm coming in from negative infinity. Anytime we talk about infinity, we're using a parentheses. And then I'm moving along my graph, and when I get to 4, 4 being the x value, I'm only looking at x's for domain, there's a hole or a break in the graph. Nothing is occurring right exactly at 4. So 4 is a place where we have a stop in our domain. It's an open parenthesis again because this is an open hole. I pick up directly on the other side of 4, let's say that's like 4.001, directly on the other side, and I continue and it goes on and on and on all the way to infinity. That arrow tells me my x values continue. Basically here I'm saying there's an x value everywhere on the graph except at 4 where there's a hole, so that's why there's a break there. If I look for my range, I'm looking from bottom to top, but kind of the same process. So if I come in from the bottom, the first place something is happening is at 3. Again, I'm looking at the y value now for range. So 3 is an open circle, meaning an open parenthesis. That's the first place where something happens across the y-axis. And I continue up, and this arrow goes up forever and ever and ever. So again, that goes on to infinity. And our range is from 3 to infinity. Let's look at example 2. Again, I'm looking at domain and range. If I start with domain, moving from left to right, I come in from the left. The first place something is happening is at this x value of 2. It's an open parenthesis, again, open circle, and stuff continues to happen across the x-axis all the way until I get to 8. That's where it stops. And then after 8, nothing else happens again. Notice on 8 I did a bracket because this is a closed, filled-in circle. There is something happening at exactly 8. If I'm looking for my range, I'm coming in from the bottom. The first place something happens, my first y value is 1. It may take you a little bit to get the hang of the fact that for domain, I'm always looking at an x value. Range, I'm always looking at y. 1 is the first place something happens, and I continue forward. The highest place something happens on my y is at 7. Again, that's a bracket because that is a closed dot. We don't care that this one is open because even though nothing is happening at 4 right here, something is happening at this 4. Okay, then we looked at 2 examples of how to graph piecewise on your own and tell the domain and range. So for this first one, you will notice that f of x is 2x plus 3 when x is less than or equal to negative 1, and f of x equals 3 minus x when x is greater than or equal to 1, meaning on these 2 different domains, something different is happening. The first half is this piece, the second half is this piece. I'm going to go ahead and make 2 tables. That's always going to be your first step, x and y, because there's 2 pieces to this graph. And then I'm going to start by looking right here at my domain. I want things starting at negative 1. Because there's a line underneath my inequality, I know that that's going to be a closed circle. And then I want x values that are less than negative 1. Things less than negative 1, like negative 2, negative 3, and on and on and on. And I'm going to draw an arrow there to denote that I could say negative 4, negative 5, and so that when I graph I know it ends with an arrow after that. Now I'm going to look at my other piece and get my domain values. So x is greater than or equal to negative 1. Again, I want to start at negative 1. Closed circle because there's a line underneath. And values greater than that would be like 0 and 1 and on and on and on in the positive direction. So again, I'm going to put my arrow. Now I have to plug my values in. Starting here with the first graph. Negative 1 times 2 is negative 2 plus 3 is 1. Negative 2 times 2 is negative 4 plus 3 is negative 1. Negative 3 times 2 is negative 6 plus 3 is negative 3, and on and on and on. For the other one, I'm going to look at the other piece of my piecewise function. So negative 1 goes in here. 3 minus negative 1, or 3 plus 1, is 4. 3 minus 0 is 3. 3 minus 1 is 2, and on and on and on. Now that I've got my two tables, I can put my two pieces of my graph. And I'm going to say negative 1, 1, close dot, negative 2 and negative 1, negative 3 and negative 3. Now that I have my 3 points, I'm going to connect them, and my arrow goes in this direction because I could also say negative 4 my x value, negative 5 my x value, and I would continue to plot. On the second piece, I'm going to start at negative 1 and 4. Again, close circle, and then I'm going to plot 0, 3, and 1, 2. And I'm going to continue in the positive x direction because I could say 2, 3, 4, 5, on and on and on. Now we have our two pieces of our graph, so we want to label our domain and our range. For our domain, we're coming in from the left. That arrow would go on forever and ever across the x-axis. So I'm coming in from negative infinity. There's a break right here at negative 1, but where it stops here at negative 1, it picks up here. So something is still happening, and it continues on forever and ever and ever in the positive x direction. So it goes to positive infinity. As far as my range is concerned, I'm going to start at the bottom. It's coming in from negative infinity because there are two arrows there. There only needs to be one, but there are two coming in from negative infinity. And as I continue to scroll up, my highest value is right here, and that y value is 4. It's going to be a bracket because that was a closed circle, and that's my highest y value. That's it for that problem. So it's kind of a long process. Note that there are two parts. We made two tables. We started by looking at the x values. We plugged in to find our y values. We graphed our first piece and our second piece, and then found the domain and range. Let's look at one more problem together. If I'm looking at example 5, you should notice that there are 3 pieces to this piecewise function. So in this case, I want 3 tables. The first one, I'm going to start at negative 2. That's kind of a correction to your notes. I'm going to start at negative 2. You'll notice there is no line underneath the inequality, so that's going to be an open circle. And then I want everything less than that, so that would be negative 3, negative 4, and on and on and on. So I'm going to draw my arrow. My next piece is from negative 2 to 3 and everything in between. At negative 2, it's a closed circle because it's a line underneath. At 3, it's an open circle. In between there, I can pick any value I want. I'm just going to go ahead and pick 0. I could pick negative 1, 1, or 2. That doesn't matter. You could do any of those. I'm just picking 0 because it's kind of dead center for me. Let's look at the last piece. We're going to start at 3. Again, an open circle because there is no line underneath. And values greater than that. 4, and maybe 5, and on and on and on. And now we need to plug those in. So starting with the first one, I'm plugging in negative 2 to 4. Now, there is no x value. There's nowhere to plug anything in, so the answer is simply 4. And the same thing occurs for every other value. Because there's nothing to plug in, the answer is always 4 as long as x is less than negative 2. So that part's done. The next part, I'm plugging into x squared. So negative 2 into x squared, negative 2 squared is 4. 0 squared is 0. 3 squared is 9. The last part, I'm going to plug into the last piece. 3 goes in for negative x, so negative 3 plus 6 is 3. Negative 4 plus 6 is 2. Negative 5 plus 6 is 1. Okay, I've got my 3 tables. I want to make my graph. And then lastly, of course, I'll double check my domain and range. Notice that I am kind of doing a sketch here. As long as I can read it, that's fine. I just want a general idea. If I start at negative 2, 4, it's an open circle, excuse me. Close, close, and arrow. That one is a constant function. On the next one, I have negative 2 and 4, and that ends up getting closed in, so that's good. That one went over the other one. Now I'm going to do 0, 0, and 1, 2, 3, and 9, and that's an open circle. And that shape right there, if I just connected those 3 dots, might look like a V, but I know by looking over here that that's a parabola or a quadratic function, so I'm going to draw that parabola parabolically, and so that's going to be a U-shaped function. For my last piece, I've got 3, 3, and that's an open circle, 4, 2, and 5, 1, and I've got an arrow. that goes that way. So that's my piecewise function. Okay, I just need to do my domain and range now. So domain, coming in from the left, it's coming in from negative infinity. Something is happening on the x-axis all the way until I get here, and then I have an open circle and an open circle. So there I have a stopping point at 3. I pick back up on the other side of 3 and go on to infinity. This goes on forever that way. Looking at range, I'm coming in from negative infinity. This part would be very low. And I don't stop. I stop here, but there's something going on here, so I keep going. This stopping point is way up here, all the way at 9. 9 is the highest y value I can find. That was it for our notes today. You did have an assignment, and I changed it. It has 8 problems on it. I only want you to do numbers 1 to 4. Let me know if you have questions or come to tutorials.